Here we're going to look at kind of a standard basic example. Sorry, let me go back. All right, here we're going to look at a standard basic example of integration by parts. So the integral of x cosine of x dx. The first thing that you want to do before trying integration by parts is actually to make sure you can't do substitution. In this case, the substitution won't work because if I tried to substitute u equals x, when I take the derivative, I won't have anything to cancel out this x right here. So that's not going to work. Instead, we're going to use integration by parts. So we pick part of the function that is going to get simpler when I take the derivative. So in this case, I'm going to say u equals x. And that means my dv is left as cosine of x dx, right? Because if the first part right here is u, everything that's left over is dv. So that means the derivative of u is 1, or in other words, du equals dx. When I integrate my dv, I'm going to get that v is equal to, what's the integral of cosine of x dx? That's going to be sine of x. Now, yes, technically there should be a plus c in here, but because of, like we said, with integration by parts, you end up having an integral expression at the end, and we only care about the one constant for the whole function. I'm going to leave that off for here. So now we've got u's and v's and dv's and du's all from this original function. So we've got this integral of u dv equals the u times v minus the integral of v du. So because I pulled the u and the dv from here, I already assigned those. I use that to find my u, my dv, my v, and my du. It's just a matter of plugging in from this expression here on the right. So the integral of u dv is equal to x sine of x, because that's my v, minus the integral of v, which is sine of x, and du is just dx. And suddenly we've transformed an integral that we didn't know how to solve into an expression where this is fine, and this integral we do know how to solve. So we can actually continue to work. So we'll have x sine of x minus, and the integral of sine of x we know is negative cosine of x. Right, yes. And now we'll put in our plus c, and we get that this whole thing is equal to x sine of x plus cosine of x plus c, and that's our solution. If you want to test it, we can just kind of quickly visually take the derivative and see if it gives us the function here. So that would be, we need to use the product rule, so we get x cosine of x plus sine of x minus sine of x plus 0. The signs cancel, and we do in fact get x cosine of x, which was our original expression. So that's a basic example. Most of what you'll do on the AP test and in practice problems will look a lot like this, but we will show you two more complicated examples in the subsequent videos.